Welcome to Bethlahem Institute of Engineering. Bethlahem Institute of Engineering is affiliated to Anna University, Chennai and approved by AICTE, New Delhi. This institution was established in the year 2008.
Good morning to all. I am Santhosh of Mechanical Department. I am going to handle thermal power plant. Major components of thermal power plant are boiler, turbine, and generator. Boiler is a device which is used to produce superheated steam. Turbine is a device which converts mechanical energy, which converts kinetic energy into mechanical energy. And generator is a device which converts mechanical into electrical energy. Now, first of all, for heating water, we need fuel. The fuel used in thermal power plant is coal. Coal is stored in the cold storage room, and it is transferred by belt conveyors or manually to the boiler. Now, the coal burns in the furnace, and the water in the boiler is converted into steam. This steam is sent to superheater, and superheater again heats the steam, and this steam is passed to the turbine. Now, in the turbine, the kinetic energy of steam is converted into mechanical energy, and this turbine shaft is coupled to generator shaft, and in generator, the mechanical energy of the turbine is converted into electrical energy. Next, air preheater. The function of air preheater is to absorb heat from the atmosphere. The air preheater heats the atmospheric air and send it to the boiler for smooth burning of coal in the boiler and complete burning of coal in the boiler furnace. Next, economizer. The function of economizer is to heat the feed water. That is, feed water is supplied to economizer. Also, the exit steam from the turbine is sent to condenser, and condensation take place in the condenser. That is, change of phase from gas to liquid take place in the condenser, and this condensate is pumped by the extraction pump, and it is sent to low pressure heater. The low pressure heater heats the water that is coming out from the condenser, and this low pressure heater from the hot water in the low pressure heater is then sent to high pressure heater, and in high pressure heater again the water is heated and sent to economizer. Now economizer will heat the water in the economizer tube and sent to boiler. Now the boiler receives hot water from the economizer. By burning the coal, the hot water in the boiler is converted into steam. This steam is sent to superheater, and in superheater the steam is again heated, and this steam is converted into superheated steam. And this superheated steam is sent to turbine. In this turbine, the superheated steam, kinetic energy of superheated steam is converted into mechanical energy, and mechanical energy of turbine is again converted into electrical energy by the generator. Next, the main circuits of the thermal power plant are coal and ash handling circuit, air and gas circuit, feed water and steam circuit, cooling water circuit. Coal and ash handling circuit. Coal and ash handling circuit means uh, the area where coal and ash are handled is called coal and ash handling circuit. That is coal storage, coal handling plant, and boiler. Ash handling plant and ash storage comes under coal and ash handling circuit. Air and gas circuit. That is economizer, sorry, air preheater and superheater line comes under air and gas circuit. Feed water and steam circuit. Steam circuit means the boiler exit, that is superheated steam going to a turbine, and generator comes under steam circuit. And feed water means The condensate which is coming out of the condenser and the feed water which we supply to the economizer comes under feed water circuit. Cooling water circuit. Cooling water circuit means the water which is supplied to the boiler and turbine comes under cooling water circuit. Next, next is advantages. The thermal power plants can be located very conveniently near the load centers. That is, if we get a particular coal in a particular area, we can locate a thermal power plant near to the load center. The thermal power plant does not require shielding like required in nuclear power plants. We need shields, that is, nuclear radiation avoiding shields are placed in nuclear reactor. Here we doesn't require any shield. Unlike nuclear power plant, whose power production method is difficult, for thermal power plant it is easy if compared. Okay, that is, the power production method in nuclear power plant is difficult and dangerous, but in thermal power plant it is not difficult. Transmission costs are reduced as they can be set up near the industries. That is, the transmission lines and EB lines can be set up near the power producing units. We'll come back to nuclear power plant. The portion of steam generated can be used as process steam in different industries. That is, the steam coming out from the steam turbine can be used for industrial purpose also. That is, the heat can be used for other purpose also. Steam engines and turbines can work under 25% of overload capacity. That is, steam engines and turbines can work under 25% of overload capacity. Next, disadvantages. Large amount of water are required. We need a large amount of water for producing steam and also to uh, for cooling purpose. Great difficulties experienced in coal handling and disposal of ash. That is, in coal handling and ash disposal is a great process. Takes long time to be erected and put into action. That is, the erection of steam power plant takes long time and large equipments well compared to other power plants. Means like wind energy, etc. Maintenance and operating cost are high. Maintenance cost is also high and operating cost is also high. Also, we need skilled laborers for operating the steam power plant. With increase in pressure and temperature, the cost of plant increases. When cost of plant also increases with increase in pressure and temperature. Troubles from smoke and heat from the plant. That is, uh, next types of coals. Peat, lignite, bituminous coal, anthracite. Peat. Starting stage of coal formation is not useful in power plants. That is, the initial stage of coal is not used. That is known as peat. Lignite. Lignite is the youngest form of coals, and lignite is most often used in power plants. It is youngest form of coal. It is soft and ranges in color from black to shadow brown. As a result, it's sometimes called brown coal. The lignite is also known as brown coal. Lignite is mainly used for power generation and accounts of 70%, 17% of world coal resource. That is, 17% of coal resource contains lignite. Sub-bituminous coal. After millions of years, continued pressure and temperature convert lignite into sub-bituminous. The next stage of lignite is sub-bituminous coal. Next, after sub-bituminous coal, it becomes harder and blacker than lignite and sub-bituminous. That is known as bituminous coal. Okay, 52% of world's coal resource contains bituminous coal. Anthracite. Anthracite is the most mature coal and has the highest carbon content of any type of coal. It is frequently used for home heating and accounting for about 1% of world's total coal resource. Represents a very small portion of overall market. Fuel handling. Next topic is fuel handling equipments. The fuel handling equipments contains coal delivery, unloading, preparation, transfer, storage, in-plant handling, weighing, feeding, and feeding the whole coal into the furnace. That is, uh, for example, in Tamil Nadu we have thermal power plant at Thoothukudi, and the coal mine is at, for example, it's at Nilgiris, and sorry, Neyveli, and coal delivery. We used to buy coal from or transport coal from Neyveli to Thoothukudi. That is what known as coal delivery. And unloading. Unloading means we will unload from the truck or lorry, etc. Preparation. The next stage is preparation. Preparation means sizing the coal into fine particles. That is, for example, if we actually the coal used in furnace is the maximum size is 8 centimeter. Okay, so that is known as preparation. We use crushers or crush mills for preparing the coal. Next is transfer take place using conveyors. We use conveyors to transfer the coal from crusher to outdoor storage means dead storage means the coal is stored in a room which is away from somewhat 1 kilometer away from the furnace. That is all not known as outdoor storage. Next is covered storage or live storage. Live storage or covered storage means the coal is stored in a place that is very near to the furnace. That is what live storage. Next one is in-plant handling. In-plant handling means transferring the coal from live storage to the furnace. That is furnace grade. That is known as in-plant handling. Next one is weighing and measuring. Weighing and measuring means suppose if we feed 10 kg of coal per minute, that is what weighing and measuring. Next, the coal is transferred to furnace. This is what coal handling system. Next one is belt conveyor. Belt conveyor is an equipment used to transfer the coal from one place to another. Okay, it consists of an endless belt moving over a pair of end drums or rollers. At some distance, a supporting roller is provided at the center. The belt is made up of rubber or canvas, whatever may be the material. Belt conveyor is suitable for transfer of coal over long distance. It is used in medium and large power plants. The initial cost of system is not high and power consumption is also low. The inclination at which the coal can be successfully elevated by the belt conveyor is about 20. Next, advantages of belt conveyor. While compared to screw conveyor, its operation is smooth and clean. Second one, it requires less space, less power as compared to that of systems. Large quantities of coal can be discharged quickly and continuously. Material can be transported on moderate inclines. Next one is screw conveyors. The screw conveyor consists of is in the shape of a screw. Okay, the screw has a groove and coal inlet. Through coal inlet line, the coal is fed into the conveyor and the screw rotates. Due to the rotation of the screw, the coal moves from inlet to outlet. It consists of an endless helicoid screw fitted to the shaft. The screw, while rotating in a trough, transfer through the coal from the feeding end to the discharge end. This system is suitable where coal is transferred over shorter distance and space limitations exist. The initial cost of the system is low. It suffers from the drawbacks that power consumption is high and there is considerable wear of screw. The rotation of the screw in the screw conveyor is 75 to 125 rpm. Okay, thank you.